My name is Mike Cortese. I went to did my undergraduate studies here at UNO, and during my senior year I met a guy named Greg Simpson. He taught cognitive psychology and the cognitive psychology lab, and I took both of those courses from him, and he encouraged me to pursue a career in cognitive psychology. So what's going to happen on this task is that a asterisk will appear on one or the other side of the screen, and then an O or a Q will appear right after that on the other side of the screen. And what his job is to do is to identify that letter as an O or a Q, because it goes up and goes away in, I don't know, probably 50 milliseconds, 33 milliseconds, something like that. What happens is that asterisk automatically draws your attention to that location, and you have to use your conscious attention to switch over to the other side as soon as possible. Otherwise, you miss that target. So it's testing the ability to engage conscious attention to do some identification. I did a postdoc at Washington University in St. Louis, and I worked with Dave Bellotta. And this is where I started doing more neuroscience-like stuff, and mainly neuropsychology. So we looked at college students, healthy older adults, people in the early stages of Alzheimer's disease. And then we also studied a relatively rare form of dementia known as semantic dementia. What semantic dementia involves is bilateral damage to the anterior temporal lobes. It's a progressive dementia like Alzheimer's, but you don't get the plaques and tangles that you get with Alzheimer's disease. You get mainly atrophy or Pick's disease that attacks these anterior temporal lobes, the cortex. And what it does is it produces a selective deficit to semantic memory. So semantic memory is kind of your knowledge, your general world knowledge, your knowledge of concepts, relationships among concepts, objects and their functions. So general world knowledge is like knowing that George Washington was the first president of the United States. Concepts, things like a dog's a pet and wags his or her tail, chases cats, those sorts of things, right? So it's these sorts of things that are lost in semantic dementia, but visual spatial skills, nonverbal problem solving skills, other non-semantic abilities are relatively preserved. So here's the suite in which we have a couple of lab rooms, and so it's going to give you guys a tour and let you see this lab. This room over here is a room that we've been using for a semantic priming project. So we do semantic priming is where the paradigm is where you get two words on each trial, and a participant names or makes a lexical decision on the second word as quickly and accurately as possible. Most people are familiar with it, at least psychology majors are familiar with the Stroop task. It's where words appear in different colors, and the participant needs to name the color of the word as quickly and accurately as possible, and that is difficult on trials in which there's a color name that mismatches the color. We call that the incongruent condition, so you get the word red printed in blue, so your response is blue. And those two things compete against each other, and either you get it wrong, you go with the wrong response, or it takes time to resolve the competition. That's what leads to the increased reaction time.
Green. Yellow. 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 Red.
These rooms that aren't our laboratory rooms are used for the laboratory courses in psychology. So I teach a cognitive psychology laboratory course, and so students learn how to do experiments in cognitive psychology, just like the semantic priming study or something like that. And they use these rooms to run subjects, program their experiments and stuff like that. Here's our other main lab room, and in this we've been doing a lot of norming studies. So where you rate, one of the studies we're doing is an age of acquisition study. So you get thousands of words, one at a time, and you try to estimate the age at which you acquired that word. So a word like potty would be acquired at a very young age, you know, doll at a very young age, whereas, you know, fax, F-A-X, would be acquired at a much later age. And, you know, this is a subjective rating, you know, but we have correlated these subjective ratings with more, you know, a subset of our items with more objective ratings that were actually, you know, where they went into kids' classrooms, asked, you know, if the kids knew these words, you know, gave them some sort of meaning test to see if they knew these words. And, you know, the results from those studies correlate pretty well with our estimates. You know, I mean, and if you think about it, you don't know exactly when you learned doll, but you know you must have learned doll when you were, you know, 2 or 3 years old, or dad, you know, 1 year old, right? Whereas some of these other words like, you know, like fax, you know that you learn later. So they do, you know, these students are actually pretty good at estimating when they learn these words, I think. And so what we do then is we use those norms to, you know, generate experiments. So now once we have, you know, ratings on all these words, we can actually do an experiment where we look at early acquired words versus later acquired words based on the ratings and see if people are actually faster at responding to the earlier acquired words than the late acquired words, and which they are. So we control for a whole host of other variables like, you know, word frequency, how often the word is encountered in normal language, word length, you know, how many letters are in the word, spelling to sound consistency, whether the word's pronunciation follows phonics rules or not, and a whole host of other variables. Or we just have people name, you know, thousands of words, and then we control for all these variables through multiple regression techniques. So, yeah. So, yep. So that's we got a couple of different computers going on here. I don't know what else to say about that.